Hey, welcome back to the Java series. So in the last episode, I've talked about how to create threads either by implementing the interface runnable or directly subclassing the class thread. So we've also talked about the use of future and the interface callable and a few other things. So in this episode, I'm gonna talk about ThreadLocal and their use in Java. So let's take a look on what is a ThreadLocal. Java ThreadLocal is used to create ThreadLocal variable. It is known that thread of an object share its variable. So that's mean the Java ThreadLocal is used to create variable local. These variables are local to the thread. So in the classical definition of thread, a thread of an object share its variable. So that's mean if an object has a variable and it has few threads, so all those threads gonna try to concurrently access this variable and mutate it or change its value or whatever. And in certain scenario, this is not desirable. So what we do is to avoid that is to use synchronization, locks and semaphore and other technique, or we can use ThreadLocal that allow us to create variable which are local to the thread. So create variable that are only local to the thread and mean only that thread can read or write those variables. So the other thread executing the same piece of code will not be able to access each other thread local variable. So in order to have a better glimpse on that, let's go to the code here. And what I did is I created the sample class. I call it ThreadLocal counter that implements the interface runnable. And I have here a counter initialized to 0. It's a private static integer. Then the method run. We override the method run here. Inside the run, I'm doing a loop from 0 to 5. Then log in the name of the thread and plus the counter. Then incrementing the counter. And finally try and sleep in the thread for about 1000 milliseconds. So let's go to the main here. I've created the two threads with this object ThreadLocal counter and gave them the name of thread 1, thread 2 and started them. So let's run the code and see the results. So go back here and see. So we have the counter 0, so the 3, 2 got inside here the first, logged 0 because the counter is 0, logged 0, incremented, then got out. Not got out, but it's running inside loop. Remember, threads are trying to run the same piece of code, so they run the same piece of code. So the first got in and it's logged 0. Maybe it's got in. Supposedly it's must log 1, but maybe it's got in the time the first was just executing this line, not before incrementing the count anyway. Or maybe my PC contains different core or whatever. So supposedly it must log 1 here, theoretically. But the second time this first got here and they logged 2. Why? Because the first one incremented in the first iteration incremented the counter by 1. Then the second thread incremented by 1. Then here the first thread when it's got inside here, it's logged 2. So 1 plus 1 is 2. So on until 8, we reach to 8. So you see, that's mean this counter is shared between two threads, and each thread try to modify or mutate the contents of this counter, the same counter. So let's change this implementation to use ThreadLocal, and we see the chain local. I'm going to create a ThreadLocal integer that's hold an integer. ThreadLocal t right here in new ThreadLocal. Then you need to give it an initial value, which is I will do by overriding a method protected, and it's gonna return integer initial value, takes nothing as a parameter but return the initial value, which is 0 in our case here. Then for logging the counter, we access the counter by using the get, just like the future and optional get to retrieve the. Then we use set here, and we have the counter, then get, then +1. So let's try to execute the code and see the result. So what we got here, the second thread got first, it logged 0, then the third 0, the second 1, and so on until 4. So we notice here, what we notice here is each thread has like 0, 1, 2, 3, 4 for each thread. Means that these two threads, each thread has its own created its own counter, local variable counter, and it's accessible only by that thread. So this is a very simple concept, but it can be useful. Let's imagine you have a web application and the client and server. So the client send a request to the server. So inside the server creates a thread attached to handle that request, and inside the request you do some calculation or whatever and return a response. But in this web application you have like 1,000 logged users. So imagine 1,000 logged user. You have that's are trying to communicate with the server. So 1,000 thread, and you need, in order to have a secure application, you have to, while doing the calculation for each user request or client request, you need to obtain some kind of user context. So could be the email and all the information concerning the user, in order to retrieve some data from the database or whatever. So user context. So this could be a very useful to use ThreadLocal. Actually, like that, I've worked a little bit with the Spring Security, and they store the user context inside the ThreadLocal. That's why. So the user context is accessible only by that thread, that is attached to the client request. So it could be very useful. So that's it for now. So comment, subscribe, and share if you like the video. If not, that's okay. Thank you, and see you in another episode.